Hey guys, welcome to Tabs Spaces. In this tutorial, we will learn about structures and unions. Before learning about structures, let's learn some basic concepts about arrays and then compare them with structures. An array is a collection of homogeneous elements which can be accessed by a common name. Homogeneous elements simply means elements with the same data type. When you declare an integer array, a block of memory will be allocated for that variable. The size of this block of memory depends on the size of the array. Since the size of the array is 5, 5 parts will be done in this block for each array element with a base address. The base address is the memory location of the first part of this block. Considering the size of integer as 2 bytes, the size of each part will be 2 bytes. Hence the memory locations for these parts will be 2016, 2018, 2020 and 2022. Variable A will store the base address of the memory block that is allocated, even though it is not a pointer variable. That's why it is also called as internal pointer variable. Check out this video to learn more about pointers. We can access the elements of an array with an array index. When an array is declared, all the locations or parts will be initialized with garbage value. When the values are provided, these values will be initialized in each location in the block of memory. Now let's compare an array to a structure. A structure is a user-defined data type that can store heterogeneous elements, that is, elements with different data type. Data types like int, float, char are predefined data types. It means the compiler already knows which type of variable will these data type represent. But in the case of structures, user or programmer has to define the data type to let the compiler know which type of variable will the struct data type represent. So let's define our struct variable. The syntax requires a keyword struct followed by an identifier. Then comes the braces with data types corresponding to the variable name. Remember to always add a semicolon at the end. If you look at the definition, a struct data type will store heterogeneous elements. These are those heterogeneous elements. Now let's look at an example. Let's say we want to store and process the details of an employee. Well, an employee has a name, employee number, and a salary. The data types to store these details are different, like char for name, int for employee number, and float for salary. That's why we cannot use arrays in these kind of situations. Now we have defined the data type. This means the compiler knows what type of data will this represent. Remember, the struct keyword and the identifier will together be the data type. Now, if you ask me if any memory is allocated to this structure, it's not. We have just informed the compiler that struct employee data type can store values with these data types. Since we have defined the data type, now let's declare a struct variable and see what happens in the memory. As you can see, we have declared the struct employee variable in the main function. You can compare the data type and the variable name. As I said earlier, struct and the identifier will together be a data type. Now we know name is of data type char, emp number is of data type int, salary is of data type float, and emp is of data type struct employee. When you declare, memory will be allocated for each member of struct in a single block. Now name is a variable with array of char data type. One char variable needs 1 byte, hence 10 char variable needs 10 bytes. So the first part in the block will be 10 bytes. Similarly, emp number is a variable of integer type. So second part in the memory will be 2 bytes. And salary is of float type. Hence 4 bytes will be the size of the last part. Therefore, the total size of this block will be 16 bytes. To store some data in these locations, we need to access them. We can access the members of struct using dot operator. emp.name will point to this location. emp.emp number will point to this location, and emp.salary will point to this location. So now we can store data in these locations. After assignment, these values will be stored in their respective locations. In this example, the struct data type is defined outside all functions. Hence, this is called global structure. If a structure is defined inside a function, it is called local structure. In this example, structure is defined inside the main function. Hence, we can declare struct variable only in the main function. If we define another function and try to declare it here, it will show an error. If you need to know more about functions, check out my video on functions. Link will be provided in the description below. Now we have an employee named John and his details. If we want to add another employee named Andy, we can declare another struct variable and store Andy's details. It may look like this. But what if we need to store the details of Jim, Michael, Dwight, and many others? Declaring different variables of struct employee data type is an inefficient way. The efficient way to tackle these kind of situations would be to use an array of structures. In this example, an array of struct employee data type is declared, and hence we can process more number of employees rather than a single employee. Now, an array of struct employee is created in the memory. Just like a normal array, we can access each of them with an index. For loop can be used to iterate through each index and read the data and display the data. Now that we have learned about structures, learning about unions will be a lot easier. Union is also a user-defined data type that can store heterogeneous elements. Defining union is almost same as defining the structure, but the struct keyword will be replaced by union keyword. You might be wondering, if this is the case, then why introduce union at all? I mean, it's the same, right? No, it's not the same. The key difference between structure and union is that union will share its memory location between its members and structures will not. Let me show you what I mean. When we define and declare a union variable, the size of the member with the largest size will be the size of the union variable. In this example, the member with the largest size is char with 10 bytes. So the size of the union variable emp will be 10 bytes. If you remember, for structure it was 16 bytes. Now all the members of union will point to this tiny block of memory. This is how memory is shared between the members of union. Remember this and you'll be able to answer some questions later. Then what about accessing each member? Don't worry, accessing is the same as in struct, but all the values will be overwritten in this block itself. Let me demonstrate this. In this step, John is stored in this location. In this step, John will be overwritten by 30, so the value John will be lost. Now, if we print emp.emp number, 30 will be printed. But what happens if emp.name is printed? If you remembered from earlier, name, employee number, and salary are all pointing to the same memory location. Hence, the output will be 30. Yeah, I agree, union makes things worse, like processing the data or printing the values. Union was introduced to lower the usage of memory. It reduces the usage of memory drastically because the members will be sharing the memory between them. This was a brief introduction of arrays, structures, and unions. Thank you for watching this video. Hit like if you like the video. Do subscribe and press the bell icon to get frequent updates from TabSoSpaces. Also, check out TabSoSpaces website. The link will be provided in the description below. Thank you.